We'll get going in just a second. Can everybody hear me okay? Good volume? Nice. Okay. So Cloud Essentials, that's the stream today. That's what we're going to be talking about. And it's kind of a redo of a previous stream, so I think it'll be good. Before we get started, if you have any questions, we have a new question system. To ask a question, all you have to do is prefix your question with either Q colon, question, or question colon, and it will show up on my Discord for me directly. So you can help me answer the questions that way. Serge Rotwerg, thank you very much for that. I appreciate it. I've seen you on the stream before. You're definitely a regular here. Thank you for continuing to return to the streams. Very nice. So I will, the things we're going to cover today is anything related to the cloud. You know, we're looking at the cloud. We're looking at cloud environments. We're looking at cloud vendors. We're looking at types of things you can buy, all the add-ons you can get, the primary things that you would use when you're operating in the cloud, among many other things. So any questions that you have today, please relate them to those kind of things so I can get those answered. It's a really big topic. You know, this is Cloud Essentials. It's not intended to be like an exhaustive list of cloud stuff because that would take way longer than one stream. So we're looking at primarily the essential things that you have to know to operate in the cloud. And it should make getting to the cloud and using it a lot easier. So if you have any questions related to vendors, components, types of cloud sites, configuration, technology, anything like that, put them in the comments and I will hook them up. So while you're doing that, we got a couple, you know, as usual, we have a couple channel updates, announcements, things like that to get through. So we'll just hit those real quick. Besides the question system, next thing is we hit 250,000 subscribers, aka 1/4 of 1 million. I put out a brief statement on YouTube the other day. I just wanted to thank everybody for getting this channel to where it is. Of course, the team and myself could not be happier. It's a fantastic achievement. It's beyond what I ever imagined for this channel, and I think, you know, what the team imagined for the channel. So it's really great. You know, we put a lot of work in, put a lot of time in Discord, put a lot of time making sure the streams are good, being consistent with the content, and it's all to make sure that people get the best kind of video and stream experience that they can. So we hit 250K, we're going for 500, a million, 2 million, whatever it is, whatever that ceiling might be. So can't stop this train. Next thing is I have some, I mentioned a sticker design last stream, so I want to officially show those today. The stickers are going to look like, let me get rid of my stream segments real quick so I can show you. Oh my god, I'm gigantic. I can like. So part of last time, these are the stickers. This is what it's going to look like. And they're kind of big. They are, you know, that's a hand, you know, for size comparison. I was trying to come up with who was going to get the stickers to start. I have about, I would say, 30 or 40 of them. So I decided to start the stickers going to go to Engineer Man Team, the supporters, Nitro Boosters, EMKC Masters and higher, and then Discord Heroes. So I will be reaching out to those folks here pretty soon to, you know, if they want to have me send them one, you know, of course you got to give me your address. You can DM that. That'll be private, but as long as I'm able to send you a letter with this in it, then I'll do it. I know some countries I don't ship a whole lot of stuff international, so for sure if you're in America and you fall into one of those groups, you'll get one of these. If you're international, I'll attempt to ship it to you, but you know, I can't guarantee it's going to go through. So you can put them wherever you want. They basically just, the lettering is sticky, so you peel off the first piece, stick it to whatever you want, and then you peel off the second piece, and then you have the letters left over. And then I've placed one on my computer, or one of my computers, and kind of looks like that. So it's kind of cool. I'll be catching up with those folks after the stream, as well as in the coming weeks, to get those stickers out to those people. If we have any leftovers, maybe I will pick some different groups, but that's going to be who's going to get them at the moment. So next is fan project review. We talked about the very last stream of Engineer Man Stream Season 2 is going to be a fan project review. Now, I've done this in the past with the videos, but it was only about a 5-minute video, and I was never able to cover a whole lot of stuff in 5 minutes. So we're going to do a stream that's entirely excellent fan-submitted projects. And I've already begun to receive a lot of them, so I'm going to pick the best ones, and I'm going to show them. I'm probably going to be able to show 30, 35 minutes worth of fan projects. I would say I can show at least 25, 30 projects, I would say 20, 25 around there. So send those in. If you want your project to be shown on project review, send it to projectreview@engineerman.org, and I'll put that link in the description. I'll put the email in the description as well. Again, that's projectreview@engineerman.org. Send that over, and if it's so far I need more. I need more projects. I've had some come in, but I don't have enough to fill the full slot. So definitely send that in, and we'll see what we can get in there. The last topic is going to be the Rust series. Rust is going very well. I've received tons of positive feedback on that. I think it's really helping people. Of course, making the videos is also helping me, so everybody wins. Everybody learns Rust, and everybody's happier. It truly is an amazing language. As I dig deeper into it and I make these videos for people, I realize how powerful the language really is. So I am trying to do 2 videos a week. There will be another video Wednesday and then Sunday, and then I'll probably skip Wednesday because the stream will come 2 weeks from now. I won't release one if a stream is coming up, just because I need time to prepare for the stream and whatnot. So be on the lookout for more of those videos. I think that'll be great. And that's it for I think, all the talking points that I needed for that stuff. So let's go into some questions here. Could you run your machines from the cloud? Yes, that's kind of the whole point. Is you don't want to, gone is the day where you have to kind of set up your own server in an office or something like that. You don't have to do that anymore. There's cheap places to rent servers in what we call the cloud, and the cloud is nothing more than a massive collection of servers somewhere other than your own office, more or less. I don't know exactly where the name the cloud came from. I guess it's just because you access something and it's just somewhere out there and you never really know, but at the end of the day, it's just a server. Cloud server is nothing more than a server that somebody else manages. Which cloud vendor? So we're going to talk about several vendors, and we're going to talk about different features they offer, what makes them better or worse than the others, as well as pricing and things like that. But we're not going to dig really deep into any one vendor. I'm going to do a lot of my demonstrations on DigitalOcean just because I already have an account there and I have a lot of stuff there. So it'll just be easier for demonstration purposes, but I'm not trying to, I don't intend this to be like a sales pitch for any one service. I want to really cover the merits of groups of cloud providers because they do really fall into one of 3 groups, and we'll go into that in a little bit. Are you tackling part of, am I taking part in Hacktoberfest organized by DigitalOcean? I'm sure I'll meet that requirement just by the work I do on Engineer Man type stuff, whether it be, of course, this code or Felix or EMKC or Piston or stuff like that. So I'm sure I'll meet that without even trying. But if I don't meet the 4 PRs, that's fine. I won't, it won't be that big a deal. What about Mozilla's privacy? I see some ads today. I was talking about something. I saw ads about it. It wasn't logged in with Google. So according to, I know this is sort of off topic. It's not related to the cloud, but As far as I understand with Mozilla and Brave, they use local data to deliver ads, but they have no tracking. And I do believe them because it's very difficult to, like Mozilla and the Brave Foundation, they develop software out in the open. It's all open source. It's not hidden by any any wall that you can't see. So, when they tell me that it's local tracking, I'm sorry, it's local data, no tracking, I believe them, because if they were lying, somebody would just look at the code and say, "Oh, hey, you're lying," and I'm not convinced that they're actually lying. So, why you saw that? Maybe it was just based on the local data. Who has the best cloud services currently? I will answer that in the context of the video. I don't want to spoil that just yet. Can mods send projects for review? Yes, the Engineer Man team is absolutely allowed to send projects in for project review, and I expect to see at least one or more pieces of the checkbox party pack from you. Will the stream go over stuff like SSH that you could use to manage a cloud server? It's going to go over like the existence of SSH, but if we have time, we'll actually jump into a cloud server and kind of look around and talk about things that you should do in it. But remember, I do have another stream. You can look it up later. It's called Getting That Sweet Website of Yours Online. And that focuses entirely on like starting a cloud server, logging in, adding Nginx, configuring some security, and then loading up your site, and that's it. I think I also did like tying in DNS, to the IP of your server, and so I've already did that. If you're interested in just seeing the bare minimum it takes to get a website online in the cloud, that's probably the better stream. This stream's focused more on discussing the things you're going to encounter in the cloud and how to best use it and how to understand how all the pieces fit together. That's kind of what this stream's about. Okay, that's about all the questions I see for now. Let's jump into the actual meat of this stream. Okay, so I got my talking points. So I have a lot of talking points here, and they're not in any necessary particular order. I'll kind of jump around as I need to, but this was just sort of stuff that I wrote up. If anybody has anything to add to any of these while we're on stream here, definitely put it in the chat. I am reading the chat, or at least I'm going to try to, as I'm on here. So I'm happy to discuss topics that are not on here, and I'm happy to go further on topics that are on here that maybe I didn't go as far as you wanted. So kind of the first thing is, we're looking at cloud vendors, and these are going to be people that are offering one or more cloud services. And I've kind of broken up these into what I call top tier, mid tier, and low tier vendors. And it's important to state that when I say top tier, mid tier, and low tier, I'm not necessarily referring to the quality. I'm not saying that like Amazon is better than DigitalOcean or that they use faster equipment or things like that. What I am saying is that you get a bigger offering. You get more things that you can use. So, when we think about these top tier vendors, these Google, Amazon, Microsoft Azure, IBM, etc., these really big kind of vendors, we're talking about a cloud environment that has quite literally everything. You can get managed services for anything you can possibly imagine, whether it's virtual machines or block storage or object storage, caching, artificial intelligence, big data, all these different things. So you can expect to find all that with one vendor if you're using something like a Google, Amazon, or Microsoft Azure. However, with this is going to come some high pricing. This stuff is not, and I say high relative to the other options. I mean, the pricing for this stuff has really come down over time. There was a time in the past where if you wanted just a basic 1 gigabyte, half a core of a virtual private server, say 10 years ago, you were paying $100 a month maybe or more. And even Google offers this for, 15, 16 bucks. So everything has really came down. So when I say high pricing, I'm talking about high pricing relative to the other kind of, vendors out there. So I'm just checking my chat, saw something come in. Can I talk about cloud security? Yes. There's some security pieces of being in the cloud that I kind of see as essential, and I'll definitely go over those as we continue in this stream. Okay, so for mid-tier, and this is kind of, mid-tier is kind of what I advise most people get into, because there's not a whole lot of difference between mid-tier and low-tier other than more offering. Generally the mid-tier, the prices are almost the same as the low tier, except you get some additional things. Like I used to be on DigitalOcean back in 2000, whenever they started getting going, 2014, I think, 2013, right when they got going, and all they did was virtual machines. The problem is my need for additional cloud services grew beyond virtual machines. And because of that, it forced me to leave DigitalOcean and end up going to Google. However, in that time, DigitalOcean began to create almost all the essential stuff that I needed that Google had, and so I would later move back to DigitalOcean. So, these things evolve over time. These companies want to give you, the best cloud services they can, of course, because they hope, buy your products. So these mid-tier companies, what they offer is they offer virtual machines, and then they offer kind of a nice set of cloud features that most people need, because a lot of stuff that Amazon, Google offers is stuff you'll never need. Like unless you're doing artificial intelligence, you're never going to use, say, like GPU accelerated virtual machines. You're never going to use this kind of big data setup. But and like mid-tier cloud vendors, they don't even offer that. You can't get, well, some offer GPU accelerated, computing, but not all of them do. But the primary things you need, and we're going to discuss them down here, is, the primary things you need virtual machines, you need block storage, you need IP addressing, specifically static and floating IPs, you need scalable object storage, you need managed DNS, and you need managed firewalls. If you have this stuff, and again, we're going to go into each of these separately as we go on, but that's kind of when I think of cloud essentials, those are the things that I think of. So then we got kind of low tier vendors, and these are going to be the vendors that offer typically just virtual machines. They won't offer anything else. You won't be able to get block storage. Everything's going to be pre-configured. You're not going to be able to get even some of the most basic things like floating IPs or backups or monitoring. This is stuff that they just won't have. They're just going to offer just the bare metal virtual machine. However, what comes with that is often the cheapest pricing you can get, picking up virtual private machines for a couple bucks, something like that. The other thing that they offer is they offer this thing called shared hosting, and I don't advise anybody do that unless you are just an absolute beginner and you don't ever want to learn Linux and you just want a folder to drop files into that show up on the web, unless and you wouldn't want to use shared hosting for anything serious, but that'd be the only time you'd want to do that. But low tier companies offer shared hosting. You will now find shared hosting with top tier and mid tier companies. Like you can't get a shared host from Google. You can't get shared hosts from DigitalOcean, Linode, Dotblock, etc. Yeah, shared hosting is a joke. That's absolutely right. I mean, shared hosting had its place back in the day, and that was when we kind of got to look back in history, to make it all make sense. So, we came from a point in history where we had single-threaded CPUs. I'm sorry, not single-thread. Just single-core CPUs, multi-thread, but single core. And because of that, it wasn't really good at doing a lot of things at one given time. So if you have a single core server and you have 50 people, on that server sharing that core, then that's not going to work really well. So you're not able to slice up a single core. You're not able to say, okay, well, I'll give you 15% of one core, because that's just really bad performance. But over time we introduced dual core CPUs, quad core CPUs, hex core, 8 core, 16 core, and beyond. So it's not uncommon for a typical server, like I have one sitting in my back room. It's dual socket, 8 core, 16 thread, so I get 32 threads. I could, if I were using that as like a server to host people on, I could host comfortably 32 people and say you each get 1 core. And that's perfectly common today, but not so common in the past. So that's kind of why shared hosting came about. Is there was no way to really virtualize, virtualized infrastructure, meaning, and when I say virtualized, I mean take 16 computers and put them in one computer and just kind of give them to people as if they were individual machines. Like when you get a cloud server in the cloud, you're going to get a machine that for all intents and purposes appears to be its own machine. You get root access to that machine. You're the only person that owns that operating system. But with shared hosting, it's not the case. It's one operating system, it's one machine, and it's hundreds of people. So not ideal. Okay, so when we talk about hosting types, this is kind of the stuff that you can find, and there's a couple other smaller types that we'll touch on if we have time, but the primary thing you're going to find is you're going to find fully dedicated servers, you're going to find virtual private servers, and you're going to find shared servers. So when we talk about fully dedicated servers, what we're talking about is a vendor will build a physical machine to spec for you. They'll throw it up in a rack, they'll hook it up to the internet, and then they'll give you access to that machine, and then you fully own it. You fully own the machine, you fully own the resources, nobody's on it, nobody's touching it, it's all you. One machine just for you. So of course, this is going to be your highest cost. This is going to be fairly pricey, but sometimes it's worth having. Dedicated servers are good when you have things that require dedicated workloads. Maybe you operate in a security sensitive environment to where it's unacceptable to have your server in a virtualized environment or on a shared environment. So in this case, maybe a fully dedicated server is the way to go. Oftentimes, they're going to bill these servers based on how much RAM and CPUs they put in them, and this can run into the hundreds or thousands of dollars per month, based on the server that you get. So this is kind of an enterprise offering for like low to mid companies. It doesn't usually make sense to get one of these. You got to really be doing a load or have a need to do this, otherwise there's kind of no point. The most popular thing though is going to be the virtual private server, and that's where it's going to be a machine, and we just talked a lot about it. It's going to be a machine that's going to be virtualized, allowing a vendor to put, say, 16 or 32 virtualized machines within this machine and then give them to people. So this is going to appear to be a real machine, but it's actually not. It's really just a slice of a given machine. Oh, should I pronounce his name? Bankston. Thank you very much for that. I appreciate that. I think it's like $10. Thank you for the 10. Very nice of you. If you have any questions, let me know. I'll be sure to help you out. Welcome to the stream. So one thing to mention about the virtual private server as well is that the virtual private server will allow you to resize it up and down easily. I forgot to mention that. Like with a fully dedicated server, oftentimes you get the machine and then that's the end of it. They put it in the rack and that's it. If you ever wanted to expand the RAM, you would have to actually probably redo a contract with the company. They'd have to pull the server, open the case, put the RAM in, close the case, put it back in the rack, and then that's how you get more RAM. With a virtual private servers get mounted into machines as soon as you need them. So like if you turn off your VPS and then you turn it back on, it's not guaranteed that that's going to be in the same machine that it used to be in. And the reason they do it that way is because you don't often pay for the server when it's off. And the only way they can do that is to allow them to mount different machines into that machine, if they need it. So it really is virtualized. You're not paying for any like permanent chunk of actual a machine. So the other thing is you only pay for what you need. You can resize this up and down whenever you want. Typically you're paying for like 1 core, 1 gig of RAM, 1 core, 2 gig of RAM, 2 cores, 4 gig of RAM, and so on. And they have thresholds, like you can't get 16 cores and 1 gig of RAM. It has to stay within kind of a sliding range. So you can't customize it too much, but it's good enough. And virtual private servers, that's going to be really competitive in cost. I mean, right now, let's have a look over here. So like with DigitalOcean, you could pick up a virtual private server for $5 a month. Like that's really cheap. With Google, you could pick up a virtual server for probably as cheap as like $12 a month. And then, Linode, I think is also 5. Dotblock, I think is also like 10. Amazon, I think you can pick one up for around 18. And excluding the free tier, they have a free tier that just gives you free VMs for a period of time. But once you're past that, I think about $10. I don't know about Azure, IBM. Those are probably more expensive. They probably don't have a $10 offering, but I'm not 100% confused. Yeah. Zach said, be prepared for super confused Batman pricing with any of the high tier. Yeah, that's absolutely correct. It's true of GCP. It's true of AWS. A lot of these things are by the minute billing, and some of them bill based on RAM. Like they say, okay, if you have 2 gigs of RAM, we're going to bill you at, 0.01 cents per RAM hour per gigabyte or something crazy. So oftentimes it leads to convoluted billing. With mid-tier companies and low-tier companies, the billing is generally more straightforward. It's not as complex. It's usually just, hourly or minute billing, but they're not like nickel and diming you. Google, Amazon, Azure, IBM, all of them, they're going to nickel and dime you for a lot of things. Like you have 30 gigabytes of storage. We charge $0.001 per gigabyte per minute, unless it's attached to this kind of machine, and then it's this much, and it's just kind of weird. So just when you go look at the pricing, just be prepared for a little, little type of frustration. The last is shared server, and we're not going to cover this, too much, just because shared server is not ideal. Again, anybody that's on this stream, anybody that's in this community, anybody that's watching Engineer Man video, of course, you're interested in technology, you're probably going to want to just go for the VPS, but just so you know what the shared server is, it's physical hardware deployed and shared. It could potentially have hundreds of clients, and your resources is not guaranteed. The problem with shared servers is that if one person on a server takes up all the CPU, then that's it. There's no more CPU. If one guy is using 100% CPU, and another guy comes in and uses 100% CPU, now it's distributed 50-50, and then your workload has a hard time working. So it's just not ideal. However, you could pick up shared hosting for 50 cents a month, $1 a month, maybe. Some probably even free, for a while. But I don't advise, you do that. Okay, so now we're digging into the actual essentials piece. This is the components in a cloud environment. Now this is going to apply to all high tier and mid tier and some low tier companies. So we don't have to really speak about a specific vendor anymore. We're talking about now the actual essential pieces in the cloud. The first, of course, is the virtual machine, and that's going to be your actual server. Vendor locking. Yes. Yeah, vendor locking, that's a good point. Let me answer that real quick. So Nico Bronzik, can you say something about vendor locking? So vendor locking is this idea that you get so ingrained with one vendor that you're not able to leave. So like maybe you do it the Amazon way, but the Amazon way doesn't work with Google or DigitalOcean. And that's kind of this concept about vendor locking. Whereas some companies, allow you to say create a virtual machine and then export that machine to move elsewhere. Other companies do not. So you got to watch out for that. It's easy to get yourself vendor locked with one particular vendor just because they're having you work in their kind of infrastructure and their framework. And by doing so, you sort of lock yourself into that one vendor. So you got to be cognizant of that. because sometimes it's very hard to leave. Sometimes you get so ingrained in one place that it's very hard to pull your stuff out. So for virtual machines, you're mostly going to find Linux. Sometimes you're going to find Windows. Windows has a very small market share in the cloud, but which is not to say that there aren't huge data centers full of Windows servers. It's just to say that there's immensely more Linux servers. So with low tier and mid tier companies, you're actually not likely to even find a Windows offering. And this is often because there's usually complex licensing requirements when it comes to using Windows in the cloud, and oftentimes companies just don't want to deal with that. So it's not uncommon to go to a cloud host and have it only be Linux. And at least for the companies that I've posted in mid-tier, low-tier, you're not going to find Windows at any of these. So as far as the images, Windows, again, we're not going to talk about that. I don't even advise using Windows, so we're going to spend no time discussing Windows really. As far as the images for Linux, you're usually going to find the newest images for leading distributions, but for mid-tier companies and high-tier companies, you're going to usually have a way to install your own image. So if you have a custom image that you like, you can just upload that into their system and deploy it on a virtual machine, and you're good to go. So I mention that because I want to say that you're not forced to use one of their distributions. However, they're going to offer the most popular distributions. And like in the case of DigitalOcean, again, I'm trying to cut down on the ret and the burn here. They're going to offer Ubuntu, FreeBSD, Fedora, Debian, and CentOS. And under each of these, they're going to offer the latest 2 versions. Like CentOS, that's the latest 2. Ubuntu, same thing. Well, they offer 3. They offer the cutting edge, and then they offer 2 long-term supports backwards. FreeBSD, same thing, latest 2, Fedora, latest 3, and Debian, latest 2. So, but again, you can upload your own, custom images. Come here, you add an image, it pops up with a box, upload, and then you're good to go. So you're by no means forced to use the stuff they give you. However, if you want to get going quick, then you got to use kind of what they have. So some hosts offer bring your own functionality. So resizing generally occurs on demand. This is important. Now, resizing, from what I understand, is you do have to take your machine offline. So you got to kind of fit that into the whole thing. Companies offer resizing in various ways. Most companies say that you can resize CPU and RAM on demand. You can resize it up and down. However, hard drive space, you can only resize it up. And that's because once you make a hard drive bigger, you can't really compress it because the data gets fragmented across the drive and there's no way to kind of shrink it. You would have to that would actually be kind of a complex process to shrink that down. It is possible, just not in a cloud environment. Can I talk about OpenStack? I don't have a ton of knowledge in OpenStack, so I can't speak too much to that. Sorry about that. So the next kind of essential thing in virtualized environments is going to be this idea of block storage. And when we think about block storage, what we're referring to is we're talking about attached drives directly to the machine. So usually when you some vendors create the machine with a drive already there. Other vendors like Google, you just get the machine and then you have to add storage. And you can add any number of storage. And this is kind of what's cool about block storage is you can attach a number of drives to your machine as if they were separate drives, and they can be any size you want, and you can attach them into your machine. Some vendors allow attaching one drive to multiple machines as long as only one of them is read and write. And that's kind of an interesting feature. So this just adds to the flexibility of what you can do. This is something that you couldn't really do locally. Imagine sharing one physical drive on 2 machines. And I think the way they accomplish this is that all the drives in cloud environments, they're all technically network attached, but they're not network attached in, like if you looked up a NAS drive, it's not network attached in that way, but it is network attached in that they can section off a piece of a drive and attach it as if it's a physical drive. So this is kind of a major thing. You can use this for various purposes. This is great if you want to have some persistent storage that doesn't, die when you kill the machine. And that's very useful for that. Kind of the next essential item here is IP addressing. And there's kind of a gotcha, with IP addressing. Testing the question bot. Okay, ignore it. Thanks for the 2. Appreciate that. When we think about IP addressing, there's a little bit of a gotcha here. So with most high and mid-tier vendors, when you create your machine, it's automatically assigned a IPv4 address. And the issue with this is if you take that machine down and you turn it back on, now magically you get a new IP. Or I'm sorry, that's not right. If you remove the machine and you recreate it, you get a new IP. And this presents some problems, of course, because imagine you run a hosting company, or not even a hosting company, but you're a small host, maybe you have 20, 30 clients, and then you realize, oh, I want a bigger machine. Or, oh, I want a second machine. Well, the problem is you create that machine, you get a new IP. Now what? Do you contact all 30 people to make them change their IPs? Well, in that case, you would have to do that, but there's a better option. And most high and mid-tier companies will offer this idea of like a floating or static IP. And this is a thing where you create one IP and then you can just point that IP to any machine that you want. And this is very helpful because this allows you to fight this problem of having to change IPs all the time. So like in my infrastructure, I host around 10 people. And what I do is I have everybody point their stuff to my static IP. It doesn't really matter what I have internally. It could be one machine, it could be 3, I could change machines, I can swap them over, whatever. The only thing that matters is that I retain that static IP forever. And that's very helpful. There was a point in time where some of these mid-tier companies didn't offer that, but now they all do. With low-tier companies, you're not likely to find that. You're going to end up with getting an IP that will change if you take the machine down, put it back up. Not ideal. So the next is bandwidth, and bandwidth has kind of a gotcha as well. Bandwidth, of course, is traffic going into your server and traffic leaving the server. And this might be a shock to somebody, but there are some companies where you need to pay per gigabyte for bandwidth. And most commonly, this is around 10 cents per gigabyte. And of course, the more you buy, the cheaper it gets. However, some companies will bake in the amount of bandwidth in with your plan. So this is common with the low and mid-tier companies. Your high-tier companies, you're guaranteed to pay for outbound bandwidth. And note I said outbound, not inbound. Inbound is always free, and that's because inbound's always cheaper, because that's like the data center downloading versus the data center sending. So you only pay for outbound bandwidth, but you have to keep this in mind, because if you switch to a cloud host that has, say, 10 or 12 cents per gigabyte, and say, I have a fun story. I had a guy one time, he wanted to contract me to build a YouTube competitor, kind of a video site where people could upload videos and they had views and it ran ads and this and that, except this didn't even really get off the ground, because as he was describing this product to me, I said, well, where are you planning on hosting it? Well, we need to host it someplace that has high availability for storage and this and that. And I said, okay, well, like, what's your pricing model? He said, well, we'll run ads. It'll be like, $2,000 per million views or whatever. And I'm thinking to myself, okay, so 1 million view at 2 minutes average watch time at, 100 megabytes used per minute, for instance. That, again, these are all fake numbers, but what we came up with is that it was going to cost like $8,000, to deliver these videos, and it was not going to be any profit at all. And this is kind of the one gotcha, is if you're not careful, you can really run that bill up. You know, it's not a big deal for static sites and this and that, but when you are using a lot of bandwidth and you're having huge downloads of media or whatnot, you can really run that bill up. So you got to kind of, yeah, super expensive. You got to kind of look at that, you know. But a big company, you can get cheaper bandwidth. The problem is when you're first starting out, you're going to pay like 10 cents a gig, 8 cents a gig, 7, something like that. But, you know, when you're running petabytes, you know, now you can negotiate and say, well, look, I'm only paying you 1/100th of 1 cent per gigabyte. And, you know, that's how like businesses like Netflix don't go out of business, you know, because you can imagine how much videos you watch, how much bandwidth that they probably pay. You know, if you multiplied the amount of videos you watch by the amount of gigabytes by 10 cents per gigabyte, you'd find that it grossly exceeds your $14 a month you give them. So the only way that they can stay in business, of course, is they negotiate their bandwidth down. And the same is true for anybody that's doing that kind of volume. But as somebody starting out, you know, it's tough. So if you buy a cloud service from like mid-tier companies or low-tier companies, you're probably going to just get like 1 or 2 terabytes per machine, and that'll be that. There might be an overage fee, but won't be that much. Like DigitalOcean, I think they give you 1 terabyte per core, and then it's like 2 cents per gigabyte overage. So, and I find that to be very reasonable. I never hit that, you know, because I'm not YouTube, and I'm not having people download gigabytes upon gigabytes per month from my sites. Next is going to be scalable object storage, and this one's kind of really important. And I call it an object because it can really be anything. It can be text, it can be blobs, it can be movies or audio, image, code, archives, encrypted files, whatever it's going to be. It doesn't really care what it is. It's scalable object storage is nothing more than just raw file storage that can be accessed through either an API or a highly available unique URL. And this is when, you know, people think of like CDNs, content delivery networks. What they're referring to is objects stored in these scalable object storages that can be accessed on demand. And the reason this is important is because if you have an application that gathers data over time, whether it's going to be backups or, you know, videos, for instance, like that guy's YouTube competitor site, of course, people will be uploading videos. You got to have a place to put that. And you're not going to put it on block storage because, number one, block storage, super expensive relative to scalable object storage. So you wouldn't want to put it there. And the second thing is block storage is a fixed size. So if you make a 100 gigabyte block storage, you're going to pay for 100 gigabytes even if there's 1 gigabyte in it. With scalable object storage, you pay per gigabyte as you add it to the actual block storage. I'm sorry, as you add it to the actual object storage area. So like with Google, for instance, they have, let me load this up real quick. You know, storage browser, you know, create a bucket called like Engineer Man. See if that's a thing. Well, I don't want to actually do this, but if I create a bucket called Engineer Man, then I can actually just load stuff into that bucket, and then I can access it either through a URL or through the Google Cloud Platform API. And you could see that, you know, storage is 2.6 cents per gigabyte per month, but that's for, you know, that's for that particular storage class. You know, they have a number of storage classes you can do that is as cheap as 0.7 of 1 cent per month. And that's quite cheap. I'm getting an urgent message. So yeah, back to what I was saying. If you have you don't want to pin yourself into a corner to where you are putting tons of information into block storage, just because. And the other thing is, like, how are you going to back that up? That's the other problem is, you know, you have to back up this data as well. And how are you going to do that if it's block storage? You know, it's tough. So with scalable object storage, from your standpoint, it's effectively infinite for all you care, because you can put 5 petabytes of data in there, and Google's not going to even complain about that. So put as much as you want in there. And what this allows you to do is it allows you to keep your machines small, keep your block storage small, and have it not slowly increase in size over time. And this is useful. The other thing it allows you to do is if you're operating on distributed infrastructure, meaning that your application runs on, say, 10 machines or 20 machines, in those cases, you can't store the data on those machines anyways, because what if a person requests a file from one machine, say machine 18, that happens to be stored on machine 4? Well, how are you going to get it? Well, you can't. So you pretty much have to use something like this to make it work. I'm just going to check for questions real quick, just to make sure I'm not missing anything here. I know we've had a couple of problems. Oh, that's a good question. Can you really migrate home PC laptop to cloud with all needed CPU, GPU, TPU? Maybe. I wouldn't advise it, but there are plenty of cloud services out there that you can use to make your computing experience a little more fluid and easier. But to actually migrate the problem with migrating your entire computing, personal computing, out to the cloud is that the cloud requires internet. So if you don't have internet, you don't have a computer, and that's of course not ideal. So that'd be the one downside to that. But there is a lot of things that you can put out there. Like one of the staff members, Calix, he's always using GeForce Now to play video games, and that uses GPUs in the cloud that just deliver the resulting video to your computer as a cloud service. So, there is technology emerging that allows more and more use of cloud services. Who really owns the cloud? Well, everybody owns the cloud. There's no one owner of the cloud, just because the cloud is a collection of miniature clouds. Each miniature cloud can operate independently of other miniature clouds, so nobody really owns it. That falls back to the whole principles of the internet, where nobody really owns the internet. Nobody can just say, oh, the internet's off. There is no big internet kill switch. You can't do that. So everybody owns the cloud. Yeah, Bip, it's a fun meme. There is no cloud, only someone else's computer. That's exactly right. There is no there is no weird cloud machine. It's all just someone else's computer, like you said. For what all purposes are you using cloud services? So I personally use cloud services for everything that I've shown here. I use it to host my virtual machines. I use scalable object storage to store my backups. I use managed DNS. I use managed firewalls, which we're going to talk about in a sec. And I used to, back when I was with Google, I used to use their queuing system, but oh, I'm sorry, not with Google. I was briefly with AWS. When I was with AWS, I used their queuing system, their simple queue system, for some old project that I had, but it's no longer a relevant project anymore, so I don't need it. So I don't use that anymore. But I don't have a really complex, cloud need, only because I'm not personally a big business. And I'm assuming this question means what am I personally using? I've of course used far more services for client projects and things like that, but just for myself, it's primarily just virtual machines and object storage for backups. So Google is giving backdoor for all your files, so why are you using Google services? I don't anymore. I pulled all my backups off of Google, but the other thing I do is I encrypt all my files before they go up to cloud storage. So, and that's actually, I'm glad you brought that up. Most high-tier companies offer you the ability to use your own encryption key. So all the scalable object storage is going to be encrypted by default at rest, However, it's going to be encrypted using Google's key, for instance. And the problem with that, of course, is it really encrypted if Google will just unlock your files for somebody? So, however, Google, and I think Amazon and other companies as well, they allow you to bring your own encryption key. The only problem with bringing your own encryption key and doing all that is that you are now solely responsible for the entire encryption mechanism. And this might not be something that you want to deal with. So there's always kind of a trade-off. You know, do you want to trust Google? Do you not want to trust Google? You know, what do you want to do? So also I'm having some internet problems here. I'm seeing some buffering occurring. Hopefully it will sort itself out. I apologize for that. It's all kind of a use case thing. I think if I was storing data, I'd first look at the data I want to store and decide how big of a deal it might be to have them storing the keys. But you know what? If you have your own keys, you want to manage it yourself, that's perfectly fine. So you're not, Google doesn't force you to trust them. They just say that if you want us to manage your keys for you, then we'll do that and it'll all be transparent. Why am I lagging? Because I live in the middle of the woods in Florida and the internet's not that great. Okay, the last thing is DNS and firewalls, and then we'll be wrapping up here. So DNS, as you know, is responsible for resolving domain names to IPs. And this is fairly simple. Some high-tier and mid-tier companies will allow management of DNS within their services. So most low-tier companies will not. They'll just make you use your registrar or wherever you registered your domain name to actually point the right A records and whatnot over to the right server, and then you won't actually be able to manage it directly within the cloud service itself. However, some companies like Google, Amazon, DigitalOcean allow you to manage your entire DNS through them. And there's some benefits to this, but again, we kind of get into vendor lock here, because when you're with a company and they hold all of your records for where everything points to, sometimes it's kind of tough to leave them. And yeah, no, I'm not using CenturyLink. I have Mediacom. I mean, it's not as bad as I'm making it seem. It is gigabit, and the upload's supposed to be like 70 megabit, but it's not always that fast. I try to stream in 1440p as well. I probably shouldn't do that, but I want you guys to have a clear picture and a good experience. So I try to stream in the highest I can possibly stream in. So generally I use DNS, I use Google Domains, me personally. So I manage all the DNS through there. But prior to that, I used to point domains over to like DigitalOcean or Linode or Google and just manage it all through there. What you do, totally up to you. It doesn't really matter. At the end of the day, it's still going to resolve. So the last thing is firewalls. And the reason I bring up firewalls is because not every company has a managed firewall. And if it doesn't have a managed firewall, the implication is that the minute you create a cloud server, it is unprotected. It is based solely on whatever you've set up for that server with a firewall on there. So when I talk about managed firewalls, these high-tier and mid-tier companies allow you to actually manage the rules right from your cloud control panel. And this is kind of nice because it allows you to set up all the ports and all the source IP ranges. Anybody that's done any firewall management knows that working with IP tables is a pain. It's not a great experience. Firewall D and UFD, a little bit better, but still not great. There's nothing like a GUI where you just pick the ports, pick the source addresses, and be done with it. I personally like that. I like that they manage that. The other reason that managed firewalls is nice is you can apply a given rule set to a number of servers, whereas if you're using IP tables, firewall D, UFD, things like that, you have to create the server, and then you got to go put that rule set in the server. So it's just another way of making your life easier. If you can do managed firewalls, then you just do that. What about Cloudflare DNS? I'm sorry if you're already. So Cloudflare is nice. I mean, they're a totally separate product. They are good. I like them, but they serve another purpose. And a lot of what they do is not just DNS, but also like DDoS protection and putting a layer between your users and your server, you know, via Cloudflare. So their service is unique, it's useful, but it's not really, you know, when we talk about a cloud environment and managing servers and whatnot, it's not something that, like, you don't work with Cloudflare in Google. You know, it's sort of a separate company, separate entity. Off topic, are you still planning on doing home security videos? Yes, but I had a lightning strike that blew up a lot of my stuff, so I'm sort of needing to repair all that at the moment. Once I repair that, then I'll get back to doing that. That happened shortly after I did it. Like, that incident happened, and then I started making really cool stuff, and then the lightning blew everything up. So I'm working on that. All right, checking for questions here. I'm looking through the chat. We got about 4 minutes left. I think I've covered everything. Yeah, NF tables as well. Any thoughts about some of the security stuff, DNS security stuff going around the news? Well, I know that Google DNS server is super saturated. So I was happy to see the Cloudflare announce their 1.1.1.1 DNS server. I think that's good. Because everybody uses Google, and people think, oh, well, Google's the best, Google's the fastest, and that's true, but you know, everything breaks to a point. So I think some of their stuff is kind of saturated at this point. That's why, like, if you just ping a Google server, you get packet loss, you know, over time. These are broken. Okay. So I think we're pretty much it. I think the chat's good here. I don't see anything else really. I think we covered everything. Firewall, scalable, IP addressing. Really, the way you can learn some of this stuff is just go create an account somewhere and just try it out and try to get something running. Between this video and my previous cloud video about getting a website online, you should be able to pretty much work effectively in the cloud and get some stuff running. I may have to do so I guess beyond this, what I could probably do is I could probably start looking at, you know, what it would take to operate effectively in a Linux environment in the cloud. And I think that's kind of a separate topic. It's something I would like to cover because I think that kind of ties everything together. You know, once you're in the command line and you're working, you know, what sort of things are you going to expect to see there and how to interact with this? Maybe that could be a future video. Probably not enough for a stream, but definitely a video. Yeah, there's tons of $10 coupons. There's also a $10 coupon at Linode. You can use code EngineerMan if you want to get, I think, 10 or 20 bucks off. I think it's linode.com/engineerman. I think that's probably still active. Let's see, Heroku's. Oh, you know what? I didn't talk about that. I really should have. Somebody mentioned Heroku dynos and things like that. You know, there's, and I'm gonna use my last 2 minutes just to speak about this real fast. Is we didn't really talk about container engines, and we didn't really talk about like serverless environments, Heroku dynos, and all these other things that allow you to build applications within infrastructure. But essentially, what these things are, we might go a little late on this stream because I totally forgot to cover this, but there's these kind of container engines that are offered that allow you to say, okay, if you want to build a Ruby app or you want to build a PHP app or Node.js app, Python, whatever, you can do so according to some general framework. And if you build your app within this kind of general framework, then you're able to deploy this app into a container engine. And what this will do is it will scale your application infinitely and automatically. And this is a really attractive option because it removes the need to even manage servers at all. However, it does allow the MySQL, Donovan Muscat, yes. Still waiting on that MySQL series. It's coming, for sure. For sure, database is coming. No question about it. We've done very little database on this channel. I think I'm going to hit that right after the Rust series. We got we got to look at some databases on this channel. We have to, because I haven't done any of that. It's a very important thing for being an engineer, being a software engineer, making good software. You're going to use a database. We got to cover it, definitely. Thank you for the 5, and thanks for being part of the stream. So container engines are nice. You want to take a peek at it. It makes it really easy to build an app that's infinitely scalable, and that's nice. The only gotcha with it is, not great on cost control. If your usage goes crazy and you end up using a ton of resources and it starts spawning all these machines and charging you hundreds of dollars an hour, well, that's a problem. So, you got to kind of keep that in check. Okay, one more question and then we're going to call it quits. Let's see. Decentralized, let's see, multi-cloud. I think it's a good question. What about multi-cloud services? So it does make sense to, like, these cloud, these cloud services are usually generic such that you can use one within the other. So you can have a Google virtual machine and you can use a DigitalOcean scalable object storage. It's no problem. And it's even better when these services are interoperable with particular tools that already exist. Like Amazon has Amazon S3, that's their scalable object storage. DigitalOcean has something called Spaces, but it's S3 compatible, meaning all the tools you use for S3 and all the scripts that you have for S3, they also work in DigitalOcean. So it's nice when things are compatible. So it's perfectly fine and sometimes desirable to use services from different places. This is particularly true if you need like failover. So if you run your site on Google, but Google goes down, then you can just cut over to, say, your Amazon infrastructure, and then your site picks up where it left off. This is probably not desirable if you're just one person, small business doing low revenue, but if you're some massive business to where if your site goes down, you lose tens of millions of dollars, then it's a pretty good investment to just replicate your entire infrastructure on a completely different vendor to allow you to just cut over. Because the expectation is that you have vendors that are within regions and you have different data centers in those regions. So the expectation is that if one vendor in one region goes down, it doesn't affect another vendor in another region. That's kind of my expectation. So it would be safe to replicate your infrastructure on, like, if your primary is in New York with Google, then maybe it makes sense to also open up one in the Midwest with Amazon, for instance. Okay, so that was the last question. I think we'll wrap it up. If you want to go further from the stream, you should come check out our Discord server. About 6,000 people on there now, with about 700 to 800 or more active at any given time. You can also chat with me if you'd like. Send me a message, say hi to me. I'm always available for that. So you should definitely check it out. Somebody will post a link in the chat here in a second. And that's a great place to go further. Lots of like-minded people over there to talk about your project or whatever you want to do. The next stream is going to be 2 weeks from today, same time, noon. And it's going to be on strategy for learning a new language. And I think this is really nice because this is going to show you my thought process on, if I go tackle new technology, how do I go about learning that new technology? And the technology we're going to be learning is Rust. So if you like Rust and you like learning new stuff, then that's going to be a good stream for you that will show you kind of the best way to approach learning something new. And in this case, something very difficult, because Rust is not super easy. It does have a high learning curve. And other than that, I appreciate all of the people who donated money today. Thank you so much. And remember, if you are a supporter, so anybody that donated today, make sure you contact one of my staff on Discord. You get a special role. And then, of course, all of the supporters and Nitro Boosters, EMKC Masters, and the team, we're going to start getting those stickers out to you pretty soon. So more on that later. Other than that, I think we're all set here. I hope everybody enjoyed the stream. I saw a lot of regulars today. Thank you for everybody who continues to support the stream, coming back and seeing me every other Saturday. It means a lot to me. And I hope everybody has a fantastic rest of their weekend. I'll be posting another Rust video, I think tomorrow, possibly Monday, but I'll get that out to you. And other than that, come see me on Discord, and I will catch you later. Take care.